Hello and welcome to another video of Grokking the Coding interview series in which we are going through the sliding window pattern, and we have encountered our first challenge problem, which is permutation in a string. Uh, let's quickly look at the problem statement and see how we can go about approaching this problem, given that we already know how to use sliding window in such problems. So, given a string and a pattern, find out if the string contains any permutation of the pattern. Permutation is defined as rearranging the characters of the string. For example, ABC has the following permutation. So you can shuffle and juggle all these letters, and whatever you get at the end will be called as a permutation. We also have four examples here. In the first one, we can see that ABC occurs with the permutation BCA, and hence some permutation of this pattern is present. In the string, we have BC, which is not present. Any permutation is not present in the string, so our response will be false here. Here we see that all the characters in the pattern are actually in the string, hence we do have a permutation within the string and we end up returning true. ABC, we have ACB, which is a permutation of ABC, hence we end up returning true. So how will we approach this problem? So essentially what we want to do at this point is we want to maintain a hash map for the pattern. So it'll be a constant time operation where we just go ahead and create a hash map of the pattern, and we will iterate through our string, say in a window of the size of the pattern. So in this case, with um, window length of the length of the pattern. So in this case, it'll be 3. And we will go ahead and simply explore all these options. And whenever we encounter or whenever we see that the frequency or the character frequency of the window or all the elements contained within the window is equal to the character frequency of the pattern, we'll simply return true. Otherwise, if we wouldn't encounter such scenario, we simply go ahead and return false. Again, our implementation will more or less be exactly the same as we have been implementing other problems. So at this point, we have had enough exercise so that we know what the building blocks of the implementations are, where the conditions would go, and so on. So let's go ahead and try to implement the solution here. And at the end, we'll also speak about the space and time complexity of our implementation. So, as the first step, I'll go ahead and import collections. So, I mean, we could go ahead and implement it on our own, just trying to keep the code clean. We have a pattern frequency hash map where we'll go ahead and use the counter. This where the counter from the collection simply goes ahead to create a hash map with the count of all the characters in the pattern. We also have a char or window frequency. We have a window start, and we also have window length. So window frequency is a dict, window start we initialize to 0, and window length is simply the length of the pattern. Or we don't actually need win length. Let's do it. So we don't have to calculate it over and over again. So at this stage, what we want to do is for window end in range, we know the exercise len of one. We get the char, which is stir1, and index with window end. If a char is not in a window frequency, then initialize it to 0 and we increment it by 1. If you see, this has been pretty standard through all our previous implementations. So at this point, we have added the character into the window frequency hash map. And what we want to do at this point is we want to check if window end is more than or equals to window length minus 1. It would mean that the size of our window at this point is equal to the length of the pattern. And why I'm subtracting 1 here is because window end is an index and window length is actually length. So just to make that offset equal, I'm subtracting 1 here. Once we have this uh, condition, I essentially want to increase the window start by 1. However, the mechanics of increasing or shrinking the window is we again want to also update the hash map. So how do we go about updating the hash map? We simply see if the character corresponding to window start in stir1 is if it's equal to or the frequency of the character which is corresponding to window start in string 1, if it is equal to 1, we just entirely remove it from the hash map. Otherwise we just reduce it by 1. And it's again a very standard like exercise which we have been implementing in other problems as well. So if window frequency stir1 uh, window start, if this is equals to 1, then we want to remove this from the hash map. Otherwise, we just want to reduce it by 1. And once I have cleaned up the hash map, I simply go ahead and increase the window start. So at this point in the implementation, what assurances am I having? So one of the assurances which I have is, of course, about the size of the window is indeed equal to the length of the pattern. And I have already cleaned my hash map to represent only the elements which are in that window. So essentially at this stage, what I can go ahead and do is I can say if window frequency is equals to uh, the pattern frequency, then I would return true. It would mean that I do have a permutation of the pattern within that window, and hence I will return true. Otherwise, I'll just exit the for loop and go ahead to return a false. So let's quickly do a check and see. So what a couple of things I need to validate at this point is if this will be more than equals to or simply more than. This is where I'm a bit unsure. Rest, I think I'm in line with how I've implemented stuff. Rest seems okay for me. So let's go ahead and like In case we have made any indexing errors into the hash map, or any other way, we'll encounter it right now. So let's try to run it and see if it makes sense. Okay, if care not in, where was this one? There won't be is. Okay, seems like we did make a mistake somewhere. Uh, what I would be interested in seeing at this point is essentially what my a string looks like at this point. And I want to see if I am making an error here. So okay, I'm missing one character here. So let's see if this would resolve what I want to do at this point. Yeah, indeed. So I was a bit unsure about that equals to sign, and seems like it is what is causing the issue. And if you see, we are considering essentially all the permutations. Okay, so this. Okay, so it seems like our implementation is working fine. I hope. I mean, let's quickly go ahead and speak about the runtime and space complexity of the implementation. The runtime complexity, again, as we are iterating through all the elements of the string ones, it'll be O of n essentially. When it comes to space complexity, we can have a pattern. We can also have window frequency, and these can both contain 26 characters. So again, the operation will be a constant time operation, as we spoke on in the previous implementation as well. Yeah, I really hope you found the explanation clear enough. I'll go through their solution as well, and in case there are some differences, I'll make sure to highlight them in the next video. I hope you enjoyed the video. Please let me know in case there are any questions or something was not clear. I will make sure to improve it in the next video. Until we see each other again, have a great day.